In this segment, I want to address the question, how will we know life when we see it on another planet? If we, or when we, and as we explore Mars, for example, how do we know when we encounter life? And one of the answers to this question is one posed by the great jurist Potter Stewart. Potter Stewart was a member of the U.S. Supreme Court, wrote many opinions, but the one that most of us know him for is when he was asked to define pornography or discussing what pornography is. He said, "I can't define it, but I know it when I see it." And sadly for Justice Stewart, this is, of all his writing, it's what most of us remember. But it's, I think, a useful thing when we think about life, that many of us have a sense, if we were to encounter life on Mars, encounter some of the signs of life elsewhere, we'll know it when we see it. Well, how might we see it on Mars? How might we find signs of life? And I think a useful way to think about that problem is turn it around. Ask, if you were an alien observing the Earth from afar, how might you detect signs of life? Well, one way of detecting the signs of our advanced civilization is that we're making movies, we're making television, we're broadcasting television and radio signal out into space. And since the 1950s, we've been sending out I Love Lucy and other of those early 1950s shows. And those TV shows can now be watched by aliens 60 light years away. And there's a lot of planets, we don't know if they have life, but there's certainly a lot of planets within 60 light years. They also might detect life by some of the chemical processes life produces. Plants on Earth produce oxygen. In fact, if there were no plants, no photosynthesis in the oceans, our atmosphere would not contain oxygen. We'll come back to this later in the course when we look at the geological history of the Earth, and we'll see that a major, and in many ways catastrophic event in the Earth's history was the relatively rapid rise in the abundance of oxygen, which actually poisoned many of the life forms. Oxygen is very reactive. If it wasn't for life, it wouldn't be there. So just detecting oxygen would be a useful sign. Other things produced by life include methane and carbon dioxide. Now, there are planets where methane or carbon dioxide could persist for a long time without any biological source. So in some cases, they would not be signs of life. But as we'll see when we come to Mars, that methane is a potential signature of Martian life. And let's talk a little bit more about methane and talk about the creatures that create methane. These are called methanogens. They're members of archaea, and archaea, remember, is the oldest form of life. It was the most recently discovered. We've known about, bacteria and eukaryotic life for a long time, but archaea actually, while they're prokaryotes, have some of the properties of the eukaryotes. They're an interesting intermediate case, and we think they're the oldest case. And one of the interesting things about these methanogens is we find them in really extreme environments. You find them actually inside solid rocks. And in the case of methanogens that do things like convert carbon dioxide and hydrogen into methane and water, they're in your guts. And they are among the things responsible for your flatulence. So you can thank methanogens for that. Now, that's not why I'm talking about methanogens, but the fact that they're found in these really extreme environments on Earth. And if you look at the environments you find them on Earth, and later on we're going to be talking with Tullis Onstadt, a geologist here at Princeton, who looks at these methanogens on Earth, mostly because they're the kind of life form that could survive on Mars. They're pretty intriguing things to think about. And people recognized that one of the ways we might detect life on Mars is if there were methanogens below the surface, those would produce methane. And methane doesn't survive very long in the Martian atmosphere. In about 300 years, it's completely destroyed. So if we had no source of methane, nothing producing it, underneath the Martian surface, we wouldn't expect to see any. There was a lot of excitement over the last decade as observations first from Earth and then from a European orbiter suggested evidence on methane and even seasonal variations in the methane level. So when people observed Mars at different parts of its orbit, they would find the levels of methane would fluctuate up and down. Now, this observation was controversial. It's very difficult to observe the methane from the Earth, and in doing those observations, you have to observe it through the Earth's atmosphere. When you're studying another planet, you need to be careful about what astronomers call telluric lines. There are gases in the Earth's atmosphere that are emitting or absorbing light at the same frequencies as the methane on Mars. And this methane result has been quite controversial for the past 10 years, as some scientists seem to think they see evidence for methane in the data, while others don't really find much evidence. And that's why there was so much excitement when the Curiosity rover landed and started to search for methane. And the Curiosity rover was designed to have something called a tunable laser spectrometer, a very sensitive device that could detect methane at the level of a part in a billion relative to the other components that make up the Martian atmosphere. And with this enormous sensitivity, if those previous results were right, the Curiosity rover would see them. And one of the results that many of us look forward to was a definitive detection of perhaps a byproduct of life by the Curiosity rover. So far, we've been disappointed. In fact, the results so far don't seem to find any methane, and they appear to contradict the previous studies, and perhaps those results were contaminated. This is something where we should all look forward to more data over the next few years. Perhaps up to now, Curiosity has been looking in the wrong places at the wrong time for this flatulence produced by life underneath the Martian surface. Or perhaps those life forms just aren't there. Time will tell.